If you want to understand how interconnected our planet is, how patterns and events in one place can affect life half a world away, you've come to the right place. Hi, I'm Matthew Carrillo. I'm a geology student in Cal Poly Pomona, and I'm here to lecture on the El Niño Southern Oscillation through the use of research facts, events in history as far back as the 18th century, and relevant data across the globe where El Niño has been documented. So let's get right into this. One of the most important sources of year-to-year climate variation in the Southwest is the El Niño phenomenon. It trends across the tropical Pacific Ocean, and it is a natural but largely unpredictable condition that results from complex interplay among clouds, storms, regional winds, oceanic temperatures, and ocean currents along the equatorial Pacific. As shown, these normal conditions produce trade winds that blow from east to west. Ponding up of warm water in the western Pacific occurs, as well as the eastern Pacific trade winds pulling up cold, deep, nutrient-rich waters along the equator from the Ecuadorian coast to the central Pacific. The warmth of the western Pacific results in a hydrologic cycle with towering cumulus clouds and tropical storms that radiate atmospheric waves and disturbance across regions of the globe. Heat and moisture loft into the upper atmosphere by the clouds and storms are disrupted by high-altitude winds. Here, during an El Niño, though, the situation is disrupted and the trade winds weaken, thus reducing the upwelling of the cool waters in the eastern Pacific and allowing for the pool of water in the west to drift eastward towards South America. As the central and eastern Pacific warms, atmospheric pressure gradients along the equator weaken, and the trade winds diminish even more. These changes in sea level pressure of the atmosphere are characteristic of the strongest El Niño, and were identified as the Southern Oscillation by Sir Gilbert Walker in the early decades of this century. Here we're looking at a chicken and egg relationship that exists between the changes in ocean temperatures and changes in the winds. The two sets of changes reinforce and drive each other, but neither is clearly the initiator of El Niño. Ocean temperatures and surface winds interact to form the complex process. The interactions can be set off by subtle changes in one another, by buffering from other parts of the tropics, or from regions beyond the tropics. Such a complex interplay and its uncertain origins are the primary limitations on our ability to predict El Niño. As the waters of the central and eastern Pacific warm, the powerful tropical Pacific storms begin to form further east than usual. As the distribution of storms spread east along the equator, their influence on global weather systems also changes. Most notably, the jet stream over the North Pacific Ocean is pulled further south than normal, where it collects moisture and carries to the southwestern United States and northern Mexico. Generations of South American fishermen have actually recognized these conditions by the disappearance of their standard catch. This tends to happen during December and January every 3 to 7 years, and because of the near coincidence in timing between these conditions and Christmas, the fishing communities have actually called the phenomenon El Niño for the Christ child. But geologic records suggest that El Niño conditions have been a part of the Earth's climate for at least several thousand years. So let's now take a look at how long scholars and individuals have been documenting the persistent effects of El Niño cycles. Between 1789 and 1792, the monsoon in South Asia failed multiple times, according to historical and scientific records. There's evidence that several other climate patterns, some of them affected by or coinciding with Asian monsoon patterns and El Niño, influenced storm tracks and westerly winds near Europe. According to some researchers, the combination of climate anomalies and unusual weather led to crop failures in Europe and set the stage for some of the unrest that exploded in the French Revolution of 1789. What an insane concept, atmospheric events having a total effect on society. El Niño is certainly the best studied example of global climate change. Having coherent influences that arise from recognized physical origins, El Niño is also of a scale both spatially and in terms of magnitude of temperature deviations that is comparable to much of the greenhouse change projected in climate model experiments. The ways in which water and land resources are managed and maintained in the presence of El Niño, like variability, which is time scales of only several seasons to several years, provides snapshots of the kinds of responses that might be necessary in a climate change world. Qualitatively, the primary difference is that an El Niño is always interrupted, whereas any new state or mode of global climate would result in dominant conditions and climatic variability, unlike those of today. The warming associated with the most recent El Niños, however, has been unusually persistent. The most recent El Niño waxed and waned for over 4 years in the early to mid 1990s. Some scientists raised the possibility that heating of the atmosphere by global warming could increase the frequency and duration of El Niño events, creating longer periods of flooding and drought. So With our understanding of El Nino and La Nina, coupled in with normal conditions, we could have a better estimate and idea as to how to mitigate these issues and save total swaths of land, populations, and allow for a more safe world. So that is why we should care. Thank you.